So one of the easiest conic sections to talk about is the idea of as an ellipse. The easiest is a circle, and hopefully you're familiar with that. But an ellipse is kind of a generalization of a circle. It's the idea if you take it and you deform it. So the formal definition of an ellipse is all the points xy, so this would be the point xy, the sum of whose distances from two distinct points called foci is constant. What does that mean? Well, what that means is that if I pick this point and I pick this point, and I take this distance and that distance, so if I add this distance plus that distance, and I take a point over here, and I take the distance to that point and the distance from that point, it's the same. So a lot of people, the way they draw this is they take two pegs and they take like a loop of a string and you wrap it around the pegs, and then you run a pencil so that these two angles or these two distances are always constant, so it draws that ellipse there. It's actually a pretty neat way to do that. I strongly recommend that. If you've got the time, take two little pegs, a loop of string, a pencil, and do this, you're going to get an ellipse. It's pretty cool. And whether the foci are this way or that way, it tells us about the shape. So if the center's here and the foci, notice that that's the plural of focus, the foci are here, that tells me that the major axis is along those foci. And then the minor axis is here. The easy way to remember this is that the major axis is the one that is the stretched the longest, and the minor axis is the one that's not. So if you think of a circle with a center, along the major axis it'll be wider than the radius of that circle. Along the minor axis it'll be closer than the radius of that circle. So planets move in that kind of elliptical orbit. We have like Earth, we have points where we're closest to the sun and points where they're furthest away from the sun. And that's kind of this style here. So the center would be the sun. Sometimes we're further away, sometimes we're not. So it's kind of neat to think about. Now, again, algebraically, we have two standard equations here. So what we do, the way you determine which type of ellipse you're dealing with is really which number is bigger than the other. So if you take a look up here, these equations are pretty much exactly the same. You have x minus h squared, you have y minus k squared, you have a squared and b squared. In this case, you have b squared and a squared, respectively. So for the standard equation, a is always bigger than b. So what does that tell me? That tells me that if the number under the x term is larger, it's a horizontal ellipse, something that looks like this. If the number on under x is smaller than the number under y, it's a vertical ellipse. It stretches this way. Now your major axis and minor axis lengths are related to these values of a and b. So notice this is a squared, so we need to figure out what a is. And if the major axis length is 2a, then this length is a and that length is a. When we get to the example, it'll be pretty clear what we're doing here. And then there's also this foci distance, which tells us that if I have the center, which by the way is that h and k, if I have that center, I can get the location of the foci. I can take that major axis length, square it, subtract the minor axis length, square it, and that gives me that c. So I can go this way or go that way. So that tells me the foci location are either away from the x center or they're away from the y center, depending on whether it's a horizontal or vertical ellipse. Simple enough. There's a lot going on here, but there's actually a pretty easy way to graph this sort of thing if it's already in standard form. Getting it in standard form is a different type of exercise, but if it's in standard form, let's say it's already in x minus 2 squared, y minus 3 squared, this is over 36, this is over 9 equals 1. So we're already in standard form. Nice. So then we say, okay, all right, I know this number is bigger than that number, so we're dealing with this type. It's a horizontal ellipse. So h and k are my center, so it looks like h is 2 and k is 3. So that tells me my center is at the point 2, 3. Now, this is a squared. So a is actually 6. It's not 36, it's 6. And this is b squared. So b is 3. B is not 9, b is 3. So be careful that you do take the square roots there. Not a big deal when they're perfect squares already, but if it was like, if this number on bottom was like 26, your length would be the square root of 26. Kind of annoying, but that's just the truth. And you follow really the 4-step process. Once you've identified these 4 bits of information, it's actually pretty straightforward. Well, really 5, because you need to identify if it's horizontal or vertical. You just start drawing. You say, okay, the first thing I'm going to do is I'm going to plot the center. So that's that red dot. So that's at 2, 3. Then what I do is I plot the major axis points. So I know that that major axis length is 2a, so it's a and a. So if it's, basically we're going 6 in this direction and 6 in that direction. So I go 6 over to 8, 3. So again, this was 2, 3, so I go over to 8, 3. And then I go 6 in the other direction. I go to negative 4, 3. Then I plot the minor axis points. By the way, you can do this in any order. So the minor axis length was 3. Well, 6, but the half is 3. So I go up 3 points, and I go down 3 points. So now I've plotted the center, I've plotted these, and finally you just sort of draw the ellipse. Now this is perfect? No, but there's some interesting things. There's something called an eccentricity. There are additional features for these that allow you to really get a better feel for how the curvature goes and things like that. But honestly, in practice, you're going to maybe use software or something like this. This is about getting you a fairly good idea of what you're looking at. This is this is kind of this ugly football that I just drew, but if you were to draw it on a computer, it would be a lot cleaner. But this is better than nothing. It gets you good intuition. This is how you should proceed when trying to plot things that are already in standard form.